Greetings and welcome once again to Bob's School for Shader Hackers. Today we're going to take a look at lesson number 2, and this is the first lesson where we'll actually do something useful. We're going to disable an effect in the game and demonstrate how we can actually improve the game in 3D by disabling those effects. So this is the sequence we're going to take a look at, so let's go ahead and take a look. Let's jump right in. This basic idea is that we're going to make our very first fix by disabling an effect as opposed to actually moving the effect into the proper position. The reason being that it's far easier to disable things than it is to fix things. We don't actually have to know anything in order to be able to disable effects. In order to fix them, we actually have to have a little understanding of what's going on. And this is significant because we can actually fix a game that is otherwise unplayable by simply disabling small problems with the actual game. Let's go ahead and get started with our initial fix here. We're going to disable that bloom effect, and the debugger environment is still set up, the HelixMod debugger, plus the ball is already ready to run. So we're ready to fix our first game-breaking bug, and I would consider this halo effect on the light on the ball actually a game-breaking bug because it's not something that you can ignore while you're actually in the game playing in 3D. You can probably see these sorts of effects in other games as well. You've probably noticed the bloom effect on the ball, and there's no good way to make it actually work in a reasonable way, so we're going to find a way to disable it instead, primarily because bloom is a low value and severely abused effect. We're just going to disable it as opposed to fixing it. We could fix it, but disabling things is far simpler, and certainly we won't miss it. If we play the game without that bloom effect, I doubt that we'll even notice. So we start with looking at pixel shaders. The reason we look at pixel shaders instead of vertex shaders in this case is because if we're focused upon actually disabling an effect, it makes more sense to use a pixel shader as the target, because pixel shaders are the last element in the graphics pipeline, and so disabling it won't disable anything further downstream. If we disable a vertex shader, we can disable other things downstream, including other effects in the game that maybe we want that are doubling up on using a vertex shader. So targeting the specific pixel shader that we're interested in makes more sense for disabling, but not for fixing. If we were to try to fix it, we would actually potentially target some other shader, but for our purposes here, this will be easy enough, and we'll look for pixel shaders. Okay, let's go ahead and run the ball in 3D, and we'll take a look and see if we can find that shader. Here we are in the mighty game, the ball. We're ready to actually try and hunt down this particular shader effect. This bloom effect is the one that we're going to target as the most annoying candidate here, and being game-breaking. So we have the debugger running. We've got our red text up here at the top. Everything looks good. Going to step backwards through the shaders using numpad 1, numpad 4. This is not necessarily important. We're just looking for the number of shaders that are available. In this case, the number of pixel shaders. I do that in order to see how long it might be to wrap around how many shaders we're actually going to look at. 85 is not very many, so that seems fine. Okay, now we're going to actually try to step through all of the shaders using numpad 2, stepping up through the pixel shaders, and we're going to target this particular bloom effect and see if we can find the shader responsible for that effect. While you're doing this, I recommend actually stepping through the entire sequence of shaders at least once, so that way you can know what all shaders impact that particular effect. There are some effects that have multiple shaders associated with them, and it's worth seeing if you can find all of them that might be affected, because you might not choose the right one. So this is an interesting effect here. This is a bloom effect, but it's sort of a more subtle, more sensible bloom effect that happens on both the ball light and on the purple lights on the left, as you can see. So it doesn't actually have any impact on the one that we're targeting, so we'll go ahead and skip that one. That's clearly not it. There's one that's interesting. So that didn't actually make it disappear, but it turned it into sort of a purple halo instead. So that's sort of interesting. Certainly seems related because it definitely changed the actual shader effect that we're looking for. And if I cycle back and forth through that one, being sensitive on the keys, can see that nothing else changes on the screen except for that exact effect. So that's probably our candidate, but we'll keep looking to see if there's something else. There's an interesting bloom effect that might be related. It definitely impacted the target effect. That one seems less likely though, because it's sort of like a super bloom. It happens on everything in the scene. So since it happens on everything in the scene, that seems less likely to be what we're looking for. That one's crazy. There's interesting dropout, turning stuff white that actually would be there. Normally we get a white effect, but that purple effect actually seems like it might be related. Stepping all the way through, there's something that's interesting. It makes it move, but it makes other stuff move as well, including the bloom effect on the purple lights and on the ball itself. So since that makes other stuff move, that's not as interesting as the one that we're actually looking for. So let's go ahead and skip through. Okay, and now I recognize that little pattern on the ball there as being Pixel Shader 1. Okay, so we've stepped all the way through all of the shaders. Now we have a sense for what actually impacts our target effect. So pretty sure it's going to be that purple effect on the halo. So we're going to go ahead and step on up there and see if we can find that guy again. And there it is. So this is probably the effect that we're interested in. We'll certainly start with this one to see. If we look up here, we can see that it's Pixel Shader number 60. His CRC hex numbers are A977E84A. That seems like a good candidate for what we're actually going to try to replace. No guarantee. Usually the effect actually disappears altogether or turns white, but in this case it changed it in some subtle way to make it purple instead. But since it's impacting only this effect, this seems like a good target. So we'll save this one out using numpad 3. Saved it. We are ready to actually go take a look at that shader and see if that actually is our candidate for fixing. We'll go ahead and quit the game now and go take a look at it in the editor. Okay, we are back and we're going to go ahead and take a look at the next section. So let's go ahead and move on down. With the shader that we've actually saved off from our run there in the ball, we now need to move it into a new folder, the shader override folder, because HelixMod uses that folder at game launch and does not use the dumps folder at game launch. So we need to find that folder and copy and paste the actual shader text from there into the other spot. One thing to note is that you should be extra careful at naming files and folders, because the HelixMod is not consistent on naming the different folders. Anything that's misnamed will actually lead to silent failures, and those can be very difficult to figure out because there's nothing in the log and there's no response from the debugger itself. So be careful when you do these and be precise about the things that you name to avoid those little extra glitches that can cost you some time. We want to go ahead and copy the file from the dumps folder that'll be in the single shaders. So let's go ahead and go to the balls game directory using our handy dandy shortcut that we saved off just for this exact purpose, that saves us from having to drive around the universe to find these things. And we see our dumps folder that's actually in the game directory, and so let's go ahead and drill in there. And now we're looking for single shaders because these are the ones that are saved on the key just like last time, and we're looking at pixel shader in this case. So there are two pixel shaders that are saved. I saved two as being candidates because it wasn't exactly clear which of the two might be the actual bloom effect. One of them moved it and the other one actually dimmed it. Neither one of them actually made it go away completely. That's the kind of thing that you can expect when you're looking at the shaders. Sometimes it's not exactly clear what shader is associated with a particular item. So it's sometimes necessary to do some experimentation to actually find out what's going on. Okay, so we've got our shaders there, and we probably will use the first one. The first one made it go sort of purplish and dimmer. The second one actually moved it. So we'll go with this one, the A977 shader effect, and feel free to experiment with these if you have interest in doing it. So we're going to take that guy, we're going to copy and paste that particular file. So let's go ahead and copy that. Now we're going to navigate back up a couple of directories to the Win32 directory. Now that we're in this directory, we actually want to go ahead and create a new folder. And the folder is named shader override. And be sure not to put overrides or misspell anything without double R or something, because if, as I noted, there's no letters there, you won't get any results. Okay, so we have shader override. Let's go ahead and open that folder. Now in this folder we're going to make another folder that's called Pixel Shaders. And in this case there is an S on the end of the word there. There's not in dumps. That's part of the inconsistencies in it that make it a little extra challenging. But just be careful, and or copy and paste from someplace else that's a known working setup. So now we have a Pixel Shaders folder. Go ahead and drill in there. Now that we're in here, let's go ahead and paste our copied file. There it is, A977. We're ready to go. Now that it's actually in there, let's go ahead and edit the name. And this is another unusual thing. So it creates the name with all this extra stuff that it doesn't actually want when we're actually modifying the shader. So you want to select that section there and go ahead and delete that section, because the only thing that we want is this hex number at the very end. So let's go ahead and delete that. Now we have just the A977E840, and one thing I'll sometimes do is with it selected here, count the number of letters. 1, 2, 3, 4, 1, 2, 3, 4. We need to always make sure that there are 8 hex digits long, because some shaders will be only 7 digits long and they need a leading 0. If you don't have the leading 0, again, silent failure, no idea of like what's happening. So always good to sort of double check that operation there. Okay, so that's our file. He's been moved into the proper folder. He is ready to be edited and ready to be tested. Moving along on to the next section, we're now ready to actually make the changes to the ASM text in the file. And this is going to be the single file that we're looking at here in the shader override pixel shade. Anything that's in the shader override folder is going to be loaded at launch time by the HelixMod. Some of Helix's fixes have thousands of shaders. We obviously are only going to do this one for right now, but there's no limit to the number of shaders that you can have in this folder. Okay, so one of the first things I'd like to comment on is that we should always add comments to our code as reminders for when we come back to the code. This doesn't seem like it's necessary when you're looking at something, but I can promise you that if you add comments to the code, it'll save you time in the long run. The main reason is because when you come back to something after several months of not looking at it, you're not going to have any idea what was going on. If you look at this file and you see A97E84A, what does that mean? What effect is that actually changing on the screen? If you don't put in a comment at the top of the file that says this is the bloom effect in the game, you'll have no idea what that file was doing. Now imagine if this folder is full of 1,000 shaders and you see this particular guy. It gets even harder. That's why the comments are so useful. Also, the comments are useful in helping share the information with other people. So if you make a fix, then we can actually share that information. It's much more clear and obvious what's happening, instead of just being some strange hex numbers in the list. So please always add comments to your source files whenever you edit them, and that will help us all in the long run. Moving on to how we're actually going to disable the effect. The technique that I'm going to show you here for disabling the effect is slightly different than the way that it's shown on the HelixMod in the guide. The guide there actually deletes the code, and that's an okay way to do it, but by technically speaking, it actually breaks the rules that Microsoft put in place for pixel shaders, where the output always has to be assigned. So the technique that I'm going to show you is actually a little cleaner and a little safer, so less chance of strange effects and less chances of crashes. But the primary reason I'm actually going to change this technique from what's been documented before is that this way is easier. Simpler change, less change to the actual shader itself. And then later on, we'll probably come back to this in a later lesson where we'll actually make a little more complicated way to do this that's actually a little bit better. But that'll be a topic for another day. Now, a pixel shader is responsible for deciding what color a particular output screen pixel is supposed to be. So the idea behind this fix is that we're going to actually make the output color via this OC0ZXYZW register all zeros. So if we zero out the output color for a given pixel shader, in general, that will actually make the effect disappear. It'll make it transparent, so you can't see it on the screen. Now, of course, this is the most common approach, but keep in mind that this doesn't always work, and sometimes other techniques are required. The graphics world is known to have all sorts of different varieties. But for our purposes, what we're going to do, our main goal is we're just going to set the output color to 0. That's it. That's all there is in terms of making an effect disappear. Moving into editing the file itself, to disable the effect, we want to go to the Shader Override Pixel Shaders folder, which is where we are right now. Here's our famous A977 pixel shader. We want to go ahead and edit this file. You can see that it's the ASM source code. Everything looks fine. The first thing that we'll do is we'll put in a comment at the very top of the file. And the reason to do this is to, as I noted before, is to give us some idea of like what this specific shader is all about. Because if you come back to this months later and you look through here and you try to think, what does this mean? I suggest that uniform pixel vector plus def C1 and DCL text coord and DCL 2DS0 and mol and mad and all of this stuff isn't going to tell you what this shader does. But if we put this comment up here at the top of the file and we say, annoying bloom on ball light, then now it's clear what this shader file actually does, and if we want to come back to it and modify it for some reason, we can actually find it. So let's go ahead and always put in comments. That's a good start. Now in this editor, we're going to go ahead and look for the constants. We're going to look for this constant down here, and it's this C1 constant that we're actually going to look at with 0.5, 1, minus 0.5, and 0. No particular reason that these are significant. These are pieces that are actually in the code already, but we're going to use this to get the number 0. What we're actually looking for is this number 0 here, and we're actually going to use that in order to set the output to be 0. If there isn't a 0 that's handily available, you can always define a new constant, but it's almost always available in some other constant that's available here. So now we know what we're going to actually use. It's C1. We'll go ahead and scroll all the way to the bottom. We're going to put in one line of code at the bottom, and you can see that the output lines here are move OC0 and then move OC0. We're essentially going to do the same thing, but we're going to just replace what they actually put into that register with our zeros instead. So we'll put in a character turn, and we'll put in our comment here, which is disable game breaking bloom effect. Now the reason to put in a comment here is to actually describe why we are actually doing this particular effect. From the code itself, most often you can get some idea of like what the code is actually doing, but it's almost never clear what the motivation behind a particular change is. So our motivation here is we want to disable that game-breaking bloom effect. We can put in just the code itself, but then people are left guessing as to like why did we put in that particular line of code. So by explaining it here, instead of just some inscrutable move OC0 something something something, then it's more clear to everyone what actually it is. And it also will allow you to find this change later on if you actually wanted to copy this into yet another game, for example. Okay. So now we're going to go ahead and put in the next instruction, which is the move instruction that we're going to do here. I'm going to copy and paste this. It's fine to copy and paste this sort of thing, or you can type it in. Be careful if you're typing it in, because if you make any typos, you'll get an error at the compile time and nothing will happen on screen. Okay, now this instruction is just a move instruction, and what it means is to move from this constant register into the output color register. That's all this does. But the key part here is that we're actually going to use the C1, which is the same as our constant up here. And we're going to use the W parameter because this is X, Y, Z, and W for the different pieces of that particular register. And we're going to use the W parameter in each of these particular cases and put it into the X, Y, Z, and W of the output color register. So the net effect is that we put a 0 into all 4 of the parameters for the output color register, which in this case will disable that effect. If that's not clear, please ask questions on the board and we will try to explain it more clearly. But for our purposes, setting the output color register to 0 is almost always a good way to disable an effect. And this will be a safe fix. Nothing will crash. Everything will be fine. Okay. That's it. That's all there is to it. That instruction will move the C1 into output color 0. Every pixel will be invisible. So that should disable our effect if it all works correctly. So I'm going to go ahead and save the file. We're done with this particular one. We can go ahead and close this because now we're going to go run the game and see what happens. Next up, we need to try and see if this particular file that we've edited and changed to disable that effect actually works or not. So let's go ahead and close this folder. Now let's go ahead and take a look, and we're going to do a couple of little sequences here to give you some idea of another useful feature of the HelixMod, maybe one of the most useful features, and that's to reload the shaders live while they've actually been edited. This gives you the ability to actually change things in the shader and actually learn about what's going on with the shader and possible ways to make it do what you want it to do. So let's go ahead and run the ball. Oops, and get 3D ready. And we're back, and it's in 3D. We can see that in fact actually the bloom effect is gone. Now isn't that impressive? So that single line of code there, setting that to 0, has actually managed to remove the bloom effect and actually make the 3D picture quite a bit better. You're only going to see the single right frame of this particular 3D video on the video itself, but if it were still there, we would actually see it. So what do you think of that? We've actually disabled an effect, our very first. Okay, now I'm going to go ahead and switch back to the desktop and leave this running. Now that we're back here, we've managed to actually disable the effect. It's amazing. Now we're going to experiment with this. So we're going to go ahead and fetch our pixel shader back from what we were looking at before. So let's go ahead and find this guy again. And it's shader override pixel shader and 8977. So here's our guy with the actual fix that we put in. So now as an experiment, we're going to scroll to the bottom and we're going to change it to be from output 0 using the C1 register with dub dub dub. We're going to change it to YYY. And the reason to do that is we're going to look at this. We see C1, and so the XY here, this is a 1 instead of a 0. So this is just a little experiment to see what actually happens if we make this YYYY. And that will actually be using a 1 into the output instead. So instead of making it all 0, this is going to make it all 1s instead, which in theory would make it more bold. So save the file so that it's ready to go. Switch back to the ball. Still in 3D here. Now the key here to use is F10 on the keyboard. So I'm going to hit F10, and voila, you can see that it actually changed it from being all gone to being all there. So that actual effect there is actually centered in that particular box. So that gives you some idea of how you can actually alt tab out and experiment with these things. Let's do one more for interest's sake. Let's go ahead and try the next one. You can see that it filled it with all 1s, which is full white in this case. So we're going to try another combination here, and this one is going to be C1 YW, YY. And so now this idea is the Y is still 1, the W is 0, and it's 1, 1. So if this were RGBA, which is the alternate form for this, red, green, blue, alpha, because this is a color register, so that would be making the green be 0 with red and blue still being bright. So let's go ahead and give that a try as an experiment. Save the file, switch back to the ball. Here's our crazy white box. Now I'm hitting F10. Now you can see that we changed the color of the box from being pure white to now being a bright purple. So I hope that gives you an idea of what you can do in terms of experimentation to see what's actually happening with a particular shader and try different things to see what actually happens. So in this case, we've made it purple by setting the RGB to a specific type. Okay, now the important thing to note there is that F10 is extremely useful for reloading any shaders in the folder that you've changed, and that gives you the ability to actually do these back-to-back experiments and try to find what actually might fix a particular broken effect. If you have any questions about that, of course, don't hesitate to ask. All right, I'm going to put this back to www, which is going to be our make it invisible mode instead. So it's going to be invisible. Going to go ahead and alt tab back in and make sure that works. Make sure I didn't make a typo. F10, and it's gone. Now we're back to being happy, clean, less broken game. Okay, I'm going to go ahead and exit. And we are done with that. Thanks, Ball, for crashing. Okay, we're done with this particular section. And in fact, actually, that's it for the lesson. Now it's time to move on to the quiz. Okay, we're ready for the quiz. We're going to demonstrate that we actually managed to disable an effect by making before and after screenshots. You know there's nothing more fun than before and after screenshots. So that'll be fun to see how we can actually change this from a broken game to something that's actually getting a little bit closer to being playable. So ready for the quiz? Let's edit the shader and go ahead and comment out that line of code. Go back to the place that we were before, pixel shaders. Here's our guy. So now we're going to comment this out with the // save the file. So now it's back to being normal. This is back to running the game the way it normally is. And we will go ahead and run the ball in 3D again in order to take our snapshot. And we're back in the ball. So our heinous effect is back. Now it's time to make a snapshot of that particular annoying thing there. Alt F1, image captured. Good. Now we're going to Alt Tab out. Get back our A977 folder. We're going to come down here and get rid of those comments. And one more thing to note here, actually, that I've neglected to mention before. We're actually going to outdent any code that we actually modify to a particular shader, where outdenting is, this is indented and this is outdented to the left. And the reason to do this is to make it clear what we've added to the file versus what was actually in the file originally. So as a shader hacker, this is just a convention that we use to make it clear when somebody is looking at a particular file to understand what actually changed, and it separates our code from the original code. So hope that's a little bit helpful. All right, we've got our effect back in. We're switching back into the ball. And here we are. I'm going to hit F10. And nothing happened. Switching back out. It didn't save the file. We've got a red mark up here, so got to make sure that we save the file to actually make that change happen. Okay. That's the sort of thing that you can have that happens with using the debugger. Switching back in, trying one more time. This time, F10, and it's gone. That is crazy. All right, now we're making a screenshot. Got our before and after pictures. We are ready to roll. So this is done for the ball right at the moment. Let's go ahead and exit. And we can go ahead and close the edited file here, and we're done with that. Okay, now with our two snapshots that have been saved into the usual NVIDIA images folder, we're going to upload our snapshots using the special unload link. So we can open this in a new window, and we'll go ahead and put him over here so we can keep track of what's going on. Now we're going to go ahead and choose the file that we want to get, and the place we're going to look at here is the images folder. We have two files here that are ready to go. This is before, this is after. So let's go ahead and open this file. Oops, it's wrong type. Got to change it again. Do the regular dance here. So I'm going to go ahead and copy and paste this to make a copy. Because we can only upload the right kind. Edit the files, type. Yes, while we're here, we'll go ahead and do this one too. Just going to do it from the keyboard. And while I'm at it, I'm going to go ahead and rename these. So this is so that we don't conflict with other people's effects. So this one is before. Name these how you prefer. And after. So let's start with before. Upload the file. That looks like a good little snapshot. You can see in this picture we have like a little bloom showing there, so that seems fine. I'll go ahead and upload that file. Okay, let's go ahead and upload the second one. And after. And now in this one you can see that the bloom is gone. Glorious. Okay, that looks pretty good. Now we're going to go ahead and open the files in a second page so we can get the files easily. This is a special link called List Files. So I'm just going to drag it over here and that'll fetch that thing there. So you can see that I just uploaded these two new pictures, after and before, and the reason to do this is so it gives us easy access to the file names for these files. So now we're going to go ahead and navigate to the personal wiki, and that's in the upper section here. So I'm going to open this in a new tab so that we can edit our particular file and keep this so that we can actually see what we're doing. Okay, I'm going to hit edit. And while I'm at it, I'm actually going to go ahead and change this code because I think it's more interesting to see the actual code that we changed instead of that other file there. So I'm going to take all of our code here, close that guy. You can set this up however you prefer. There's no right way or wrong way for this particular sequence. I'm just going to do this as an interesting little tidbit. So that's that guy. Now we'll bring back up our thing. Now we've got it ready. We're going to edit the personal page, which we're doing, so we can now add in the lesson with the header bar. Lesson 2 is done. Done. First effect changed. Disabled. Okay. Keep a consistent thing here. Okay, that's what I want to say. Now I'm going to copy the text for the before image and put it into this particular block. So let's go ahead and add a let's add a little sequence here. Before, after. I'm going to take a couple of these. I assume that you can follow along what's going on here. We're trying to get the end result, which is this sequence here, to be exactly right. Okay, now we're ready to go ahead and put in the proper file name here. So we'll go ahead and switch back to the list of files. So let's take a look at this first one, which is the before picture. And the reason to do this is it gives us easy access to this link here. We can actually say this is the file. So go ahead and copy that name. Now we're going to paste it in over the top of our little sequence there. So that should be okay. Do the same thing with the after image. Copy this. Paste it into the before file name. Paste. So now we have before and after. Now it's time to do a preview to see if we like what's going on or if we made any mistakes on here. Always possible. Lesson 0 seems 1. Lesson 1 is scary, and you can see I changed the code to being the 1, including our actual code change. Then lesson 2, here it is. We fixed it. Look at that. We have before and after pictures. I hope that you had as much fun as I had getting rid of this effect. That effect was really annoying. So that's it. That's all we've got. I think I'm happy with that. I hope you're happy with it. When you are, hit Save Page. That'll go ahead and save that page for anybody else to look at as well, and to demonstrate that you actually are now a shader hacker. Bravo. So one last comment. Disabling effects seems like a really silly thing, but don't discount the power of this technique, because as you've seen from this small example, that can take away something that's very, very distracting in a particular game. So any questions, of course, hit the discussion tab or hit us up on the forum. And I hope you enjoyed this class.